Hello, ladies and gentlemen. Welcome back to Math 30-2, Chapter 2, Section 1, Accounting Principles, Part 2. So, a restaurant offers 12 flavors of wings and your choice of 3 dips. So, how many variations of wings and dip can you order? Well, 3 dips. So there are 12 flavors of wings. And as I just said, 3 dips. So that's 36 variations of wings and dips you can order. Now, so far so good? Now, of course, I'm going to throw in some restrictions. If you cannot eat the death toile hot spice or the garlic dip, notice there were 12 flavors. Now, if you can't eat the death toile hot spice, so that's 11 flavors you're down to. And you cannot eat the garlic dip, means you're down to 2 dips or 22 variations. Death toile. That sounds interesting. Now, how else can I be a food head? Well, what happens if I say you want the death toile hot spice, but not the garlic dip? So, your wings have to be the death toile hot spice. So how many choices for spices do you have? 1, the death toile. You're ignoring the other 11. Now, you do not want the garlic dip. How many dips are there? Well, there were 3. You get rid of the garlic dip, you're down to 2. So 1 times 2 is 2. You have 2 choices now. Okay? See how that goes? Note, the math isn't hard, but you've got to read the questions carefully. Yes, when I stroke out, the English teacher will come in and finish teaching the class. Now, next question. Given a standard deck of 52 cards, what is the number of possibilities of drawing a single card and getting either a red face card or a 7? Okay. Well, how many red face cards are there? No. No, sir. My apologies. A single card. So I apologize, I keep forgetting that. Drawing a single card. Well, how many ways to get a red face card? Well, how many face cards are there? There's the Jack, Queen, King of diamonds, and the Jack, Queen, King of hearts. Number red face, 6. And how many 7s are there? Well, this is 7 of clubs. This is 7 of spades. 4 of hearts. And diamonds. So there's 4. So there's 10 ways of getting a red face card over 7. Okay. Now, given a standard deck of cards of 52, so there should be a deck of 52 cards, what is the number of possibilities of drawing a single card and getting either a heart or an ace? So careful here. Number of hearts. How many hearts are there in the deck? 13. How many aces are there? 4. What's wrong with this? It's not a darn thing, but what if I've forgotten? What about the ace of hearts? This is not mutually exclusive. There's overlap. Hearts, aces. There's 12 hearts. There's 3 aces, and there's 1 ace of hearts. Yes. Really should do a Venn diagram for this. 12 hearts not including the ace of hearts. 3 aces not including the ace of hearts. And 1 ace of hearts is both. So technically, if I'm doing the formula, I'm supposed to subtract number, base, and part overlap. Technically, I'm supposed to do the formula out. Now, hang on, no. 13, 17, no. Yes. That's 16 in total. Okay? So if you're doing the formula, without being lazy, not doing the Venn diagram, you got to subtract the overlap. It's probably a little easier to do the Venn diagram. You're going parts, only is 12, bases only is 3, bases and hearts is 1. Whatever floats your boat, it's something you got to be able to do. Okay? So, what's the number of possibilities of drawing a single card and getting a club or a red? Well, here's the number. I apologize, keep going with myself. Getting a club or a red card. Well, number of clubs, there's 13 of those. And red cards, that's diamonds and hearts. Times 13 hearts, that's 26. That's 39 clubs or reds. Okay. Those are mutually exclusive. Want to get picky. Clubs, the king. 26. And overlap. So, what's the number of possibilities of drawing a single card? Number of drawing a single card and getting a heart or two. Woo! So, how many hearts? 7 plus 13. How many twos are there? 7 plus 4. And what are you about to say? What about the two of hearts? Yes! Thank you. Hearts. Deuces. There's 12 hearts that are not a deuce. There's 3 deuces that aren't hearts. And there's 1 deuce of hearts. So I should be saying subtract the number of 2 unit intersects of hearts. It's 1. 16. So there's 16 ways to draw a card, a heart, or 2. So far, so good? So what happens? Next, the other side. When I'm talking about disjointed or mutually exclusive, the number of the union of A and B equals the number of A plus the number of B. So this would be number of clubs and diamonds, number of clubs, number of diamonds, and no overlap. Now, not disjointed or not mutually exclusive, so that stress is not mutually exclusive, there is overlap. Closer. This is like hearts, deuces, 3 deuces, 12 hearts, 1 deuce of hearts. Yeah. So that's something you have to know. Okay? Now, ending up, last question. A combination lock opens with the correct 4-letter code. Each wheel rotates to the letters A to L. Suppose that each letter can be used only once in a code. How many different codes are possible when repetition is not allowed? Okay? So, I want you to start with this. I want you to pause the recording, do it, and come back and check. Right, so important points you have to note. 4-digit code. 4-letter code. 2, 3, 4. Letters A to L. Now, A, B, C, D, E, F, G, H, I, J, K, L. That's 12 choices. 12 letters. And each letter can be used only once. And notice I'm saying this twice. Each letter can be used only once, and repetition is not allowed. So, how many choices? I'm going to pause the recording here. You guys do this, come back, and we'll check answers. Okay, ladies and gentlemen, so you've had a chance to look at the question. Now, remember the tricks we talked about? Yes on a slight poopy head, accepted. Now, 4 letters. And the key here is you've got 12 for the first. You've used 1. Repetitions aren't allowed, so how many letters are left? Yes, 11, and then 10 and 9. Now, what's the answer here? I don't know, I haven't got that many fingers and toes, but 12 times 11 times 10 times 9 is, that's not right, 12 times 11 times 10 times 9 is 11880, which is B. So look at it carefully and note the math isn't hard, but you have to read the question. So I did allow repetition, I'm willing to bet A is the answer. And it's so easy to screw this up. Anyway, if you're having trouble, watch the video again or shoot me an email. Otherwise, I'll see you in class. Good luck.